In a simulated environment that mirrored the complexities of real combat, an autonomous AI-driven drone achieved what many considered impossible: it defeated a manned F-16 fighter jet. This outcome, though a simulation, signaled a profound shift in military aviation, challenging decades of doctrine centered on human piloting superiority. The drone, powered by sophisticated artificial intelligence, demonstrated an unprecedented level of maneuverability and decision-making speed. This event underscores the accelerating pace of AI integration into defense systems, raising critical questions about the future of aerial combat and the capabilities of autonomous platforms. Behind this pivotal moment lies Shield AI, a defense technology company focused on developing AI pilots for autonomous systems. Their mission, as stated by company representatives, is to ensure global peace through technological deterrence. Shield AI's foundational work centers on creating AI software capable of robust, real-time decision-making in complex and dynamic environments. This commitment has positioned them at the forefront of autonomous warfare development, attracting significant attention from defense organizations seeking to modernize their capabilities. The company's unique approach prioritizes AI that can learn and adapt, rather than simply execute pre-programmed commands. At the core of Shield AI's innovation is the Hivemind autonomous software. This system is not merely an autopilot, it's designed to be an AI pilot, capable of independent reasoning and strategic execution. Hivemind enables autonomous platforms to operate in contested environments, making split-second decisions that would challenge human operators. It's built on principles of decentralized intelligence, allowing multiple unmanned systems to act as a cohesive unit without constant human intervention. The system's adaptability is crucial, allowing it to navigate unpredictable scenarios and react to unforeseen threats with minimal latency, transforming individual drones into intelligent team players. The Pentagon's interest in autonomous systems stems from a strategic imperative to maintain technological superiority and adapt to evolving threats. Traditional manned aircraft are increasingly expensive and vulnerable in certain combat scenarios. Autonomous swarms, conversely, offer potential advantages in terms of cost, expendability, and saturation. The U.S. Department of Defense has identified the need for agile, resilient, and affordable combat systems, prompting investments in next-generation unmanned platforms. This shift reflects a recognition that future conflicts may demand capabilities beyond what conventional manned systems alone can provide, emphasizing distributed and intelligent networks. This strategic imperative has led to programs like the Low-Cost Unmanned Combat Air System, or LUCAS. LUCAS represents the Pentagon's vision for a new class of affordable, mass-producible combat drones. The low-cost aspect is critical, enabling the deployment of large numbers of these systems, creating a numerical advantage that traditional, expensive manned aircraft cannot match. The aim is not to replace manned aviation entirely but to augment it with expendable, smart platforms. LUCAS is intended to be versatile, capable of various combat roles, from reconnaissance to strike missions, operating autonomously or as part of a manned-unmanned team. The partnership between the Pentagon and Shield AI is a crucial element in bringing the LUCAS vision to fruition. The Department of Defense recognized Hivemind's potential to provide the advanced autonomy required for LUCAS. This collaboration aims to integrate Hivemind directly into LUCAS platforms, providing them with the intelligence needed for independent and coordinated operations. This strategic alignment underscores a commitment to accelerating the development and deployment of next-generation autonomous combat systems. The Pentagon is investing in Shield AI's expertise to ensure LUCAS can operate effectively in future conflicts, leveraging cutting-edge AI. One of the most significant challenges in modern warfare is the increasing likelihood of GPS-denied environments. Adversaries are developing sophisticated electronic warfare capabilities designed to jam or spoof GPS signals, effectively blinding and disorienting conventional navigation systems. For autonomous drones reliant on GPS, this presents a critical vulnerability. Operating without accurate positional data means drones can lose orientation, fail to complete missions, or even become targets. Traditional methods often require manual intervention or pre-programmed routes, which are insufficient for dynamic combat scenarios. Overcoming this limitation is paramount for true autonomy.
Hivemind addresses the GPS-denied challenge through advanced vision-based navigation and sensor fusion.
Instead of relying solely on satellite signals, Hivemind uses onboard cameras and other sensors to map its environment in real time. By continuously processing visual data, LiDAR, and inertial measurement unit (IMU) inputs, the AI system builds a robust understanding of its position and movement relative to the terrain and surrounding objects. This simultaneous localization and mapping (SLAM) capability allows Lucas drones to navigate accurately even in complex, contested airspace, maintaining operational effectiveness where traditional systems would fail. Beyond individual navigation, Hivemind enables decentralized swarm operations. This means that each Lucas drone within a swarm doesn't rely on a central command hub for every decision. Instead, they communicate and coordinate with each other directly, forming a collective intelligence. If one drone is lost or damaged, the others can adapt and reconfigure their strategy autonomously, maintaining mission objectives. This distributed decision-making enhances resilience and robustness, making the entire swarm less vulnerable to single points of failure, a critical advantage in high-stakes combat scenarios where centralized systems can be easily neutralized. Hivemind's advanced algorithms allow Lucas drones to exhibit complex cooperative behaviors and tactical maneuvers. They can execute coordinated attacks, defensive formations, and even bait-and-switch tactics, overwhelming adversary systems through sheer numbers and unpredictable movements. The AI learns from interactions, refining its strategies over time. This capability moves beyond simple coordinated flight. It involves understanding mission objectives, assessing real-time threats, and collaboratively formulating optimal responses. This level of autonomy allows swarms to penetrate sophisticated air defenses and engage multiple targets simultaneously, representing a significant strategic advantage. The integration of Hivemind into the Lucas hardware is a key step. Shield AI software must be optimized to run efficiently on the drone's onboard processors, considering the low-cost design constraints. This involves careful engineering to ensure the AI's complex algorithms can execute in real time with minimal computational resources. The partnership includes adapting Hivemind to Lucas's specific sensor suite and propulsion systems, creating a seamless interface between the autonomous brain and the drone's physical capabilities. This integration phase is critical for turning a theoretical AI advantage into a practical combat system ready for deployment. The low-cost aspect of Lucas, combined with Hivemind's autonomy, creates a significant cost-effectiveness multiplier. Instead of risking a multi-million-dollar manned aircraft, commanders can deploy a swarm of relatively inexpensive Lucas drones. Losing one drone in a swarm is strategically tolerable, unlike losing a manned fighter jet and its pilot. This economic advantage allows for higher operational tempo and greater risk-taking in contested environments, fundamentally changing the risk calculus of military operations. The ability to field numerous intelligence systems at a fraction of the cost of traditional platforms redefines force projection. Perhaps one of the most remarkable aspects of the Hivemind Lucas system is its single-operator management capability. Instead of requiring one pilot per aircraft, or even one operator per drone, Hivemind allows a single human to supervise and direct an entire swarm. The AI handles the complex, real-time tactical decisions, while the human operator provides high-level strategic guidance and mission parameters. This human-machine teaming approach leverages the strengths of both, the AI's speed and precision, and the human strategic foresight and ethical judgment. This dramatically reduces personnel requirements and cognitive load on human operators. The interface for this single-operator management is designed to be intuitive and efficient. Operators receive condensed, critical information from the swarm, rather than raw data from individual drones. Visualizations depict the overall tactical situation, mission progress, and potential threats, allowing for rapid assessment. The human operator can issue commands to the entire swarm or specific subgroups, defining objectives rather than individual flight paths. This approach ensures that the human remains in the loop for critical decisions, maintaining control and accountability, while offloading the immense computational burden of managing individual assets to the AI. The strategic advantages of the Hivemind Lucas system are significant.
Commanders can deploy autonomous swarms to overwhelm adversary air defenses, conduct persistent reconnaissance, or provide close air support without risking human lives. The ability to operate effectively in GPS-denied environments means these systems maintain operational tempo even when confronted with sophisticated electronic warfare.
Furthermore, the low cost allows for mass deployment, creating a numerical superiority that complicates enemy targeting and response. This system introduces a new dimension to military planning, emphasizing distributed, intelligent force projection rather than concentrated assets.
The development and integration of Hivemind into Lucas marks a pivotal moment in the future of aerial combat. This system is not merely an incremental upgrade, it represents a paradigm shift.
It moves beyond individual platforms to networked, intelligent swarms that can adapt and execute complex missions with minimal human oversight. This could fundamentally alter how air superiority is achieved and maintained, challenging the dominance of traditional manned fighter jets. As autonomous capabilities advance, military forces worldwide are grappling with the implications for doctrine, training, and strategic balance.
The F-16 engagement was a harbinger of this new era.
Beyond direct combat, the strategic implications of such autonomous systems are far-reaching. They could enable new forms of intelligence gathering, logistics, and even humanitarian aid in dangerous zones. The agility and resilience offered by GPS-denied swarm operations make them invaluable in scenarios where conventional assets are too risky or ineffective. However, with this power comes intense scrutiny regarding ethical considerations and the need for robust human-in-the-loop protocols. The partnership between the Pentagon and Shield AI underscores a global race for autonomous dominance, with Hivemind and Lucas positioning the U.S. at the forefront of this new frontier. The integration of Shield AI's Hivemind autonomous software into the Pentagon's low-cost unmanned combat air system, or Lucas, represents a critical leap in military technology. This system's ability to operate without GPS, coordinate complex swarm operations, and be managed by a single human operator fundamentally reshapes our understanding of air warfare. It promises to deliver overwhelming numerical and tactical advantages while dramatically reducing risk to human personnel. As this technology matures, it will undoubtedly define a new era of conflict, characterized by intelligent, autonomous swarms, demanding continuous adaptation and strategic foresight from all global powers.